So we've done our experiment, we've got our data. Now what?
We have to analyze our data.
Right. Now, remember, a hypothesis is an idea that needs to be tested. And today we're going to talk about how to use a statistical test to determine whether your hypothesis is true or not. This test is called a t-test.
A t-test is a statistical hypothesis test. People use it when they want to compare a mean, or average, of a measurement from one group to some theoretical expected value. For example, if someone claimed that more than 25% of students at Lingnan fall asleep in class, you could use a t-test to compare the actual average number of students that fall asleep to the expected value of 25% of all the students.
People also use t-tests when they want to compare the mean, or average, of a measurement of two groups, A and B. They want to decide if the mean in group A is different from the mean in group B. For example, pretend there are two groups of Lingnan students. Group A are the students in Hostel A that play mahjong at night. Group B are the students in Hostel B that prefer to study at night. Our question will be, is there a difference in GPA between these two groups? So we're comparing to see if the mean of Group A is different than Group B.
Depending on the way the question is phrased, we use a different type of t-test, either a one-tailed test or a two-tailed test. Let's look at these two different types of testing. A two-tailed test will test if there is generally a difference between the actual and expected value or between groups, but not specify which direction it's going to go. One group could be significantly greater or significantly smaller. For example, is there any difference in price between eating in the canteen or in the Lingnan house?
A one-tailed test will test either if the mean is significantly greater than a certain expected value, or if the mean is significantly smaller than the expected value, but not both. You use it when your prediction includes a specific direction. For example, is the number of students falling asleep in class greater than 25%? Is the number of students studying finance in Lingnan smaller than the number of students studying economics?
So let's go back to our hypothesis that we want to test and look at the question. The question is there a difference in GPA between Hostel A and Hostel B? So what kind of test will we need? One-tailed or two-tailed? Correct, we would need a two-tailed test.
Now let's get back to our hypothesis. Remember that every experiment has a null hypothesis and an alternative hypothesis. The null hypothesis is often the no change or no difference hypothesis. The alternative hypothesis is the opposite of the null hypothesis. The predicted difference is true. We often denote these like this.
So what will our null and alternative hypotheses be in this experiment? Our null hypothesis will be there is no difference in GPA between students from Hostel A who love to play mahjong or students from Hostel B who prefer to study at night. And our alternative hypothesis states that there is a difference in the GPA between Hostel A and Hostel B.
Notice that our alternative hypothesis does not specify whether one will be larger or smaller, since that would make it a one-tailed test.
P-value tells us how likely the difference between the two groups could have happened by chance. Every group of people you measure has some variation, and you usually can't measure everyone in that group, so you could end up with a difference just based on who you happen to sample, when there isn't a difference overall. So the p-value takes that into consideration and tells you how sure you should feel about whether that difference is real or not.
The p-value is a number between 0 and 1 and is interpreted in the following way. A small p-value, typically less than 0.05, indicates that it is very unlikely that this difference happened by chance. It gives strong evidence against the null hypothesis, so you reject the null hypothesis that there is no difference. In our example, rejecting the null hypothesis means that there is a significant difference in GPA between hostile A and hostile B. A large p-value, typically greater than 0.05, indicates that it is likely that this difference happened by chance. It gives weak evidence against the null hypothesis, so you fail to reject it. In this case, we failed to prove that there is a significant difference. P-values very close to the cutoff, around 0.05, are considered to be marginal and could go either way. Always report the p-value so your readers can draw their own conclusions. This means that the data may not be sufficient enough to derive any conclusion, and whether you play mahjong or study at night may or may not significantly affect your GPA.
Notice how the p-value helps a scientist reject the null or alternative hypothesis instead of proving that either of them are correct. But just because a null hypothesis is rejected does not necessarily mean that the alternative hypothesis is true. Further study is usually needed. A scientist's job is never over.